Okay, prep chapter section 3. We're talking about functions and function notation. You guys, we've all dealt with this in pre-calculus. Now we're just hitting a little review here. A relation is a set of ordered pairs, so we plug in some x and get a y. All right. Well, a function is a relation, but it's a special kind of relation. It's a special kind of relation that when we plug an x in, we're going to get the same y every time we do it. So to help explain it a little bit better, I have a little paragraph right here talking about functions. All right. So what it's saying, if we have a relation, just a simple relation, if I pick any number out for x, say I pick 2 out. All right. I could get 4 for y, or I could get 6. You know, every time a relation is, I'm just going to pick a number for x, and every time I pick a number for x, I'm going to get one for y. It doesn't matter which one it is. I'm just going to get a value. Now, if it's a function, that's relation. All right, it is also a relation. So anytime I pick an x value, I'm going to get a y value. The special thing about a function is, though, is when I pick the same x value, I better get the same y value. So, for example, if I pick 2, and out with it becomes a 4, every time I draw 2 out of the x box, I better get a 4 coming out of the y box. If I don't, then it's not a function. Okay? So a quick little thing about functions there. Difference between a function and a relation. Function notation. A lot of times, you guys, we've dealt with f of x, and up until probably last year when I corrected you, you probably just thought it was a fancy way of writing y equals 2 something. But actually, it tells us that we have a function. And it tells us that we have a function in terms of x, meaning that the x is the independent variable, and the dependent variable is y. So independent meaning the y depends on what value the x is. Okay? So we have an example right here. For the function f defined by f of x equal to x squared plus 7, evaluate each of the following. Well, here, all right, we're going to plug in anywhere, basically, so it's saying f of 3a. So what it's saying is anywhere we see an x, we want to plug 3a into. So f of 3a is 3a squared plus 7, or 9a squared plus 7. All right. If we want to plug in f of b minus 1, all right, anywhere we see an x squared, we're going to plug in b minus 1. All right, so we'll have f of b minus 1 equals b minus 1 squared plus 7. And of course, we can boil that all out and everything too and simplify it. For the next one, for c, evaluate f of x plus change of x minus f of x all over change of x. So what it's saying is we want to plug in f plus change of x first, and then we're going to subtract the original function, just f of x. This is the original function here, sorry. So we're going to plug that in at x plus change of x first. We're going to subtract the original function, and we're going to keep it all over change of x. So for c, f of x plus change of x would be x plus change of x squared plus 7 minus, sorry about that, minus our f of x, which is minus x squared plus 7, all over change of x. Well, we can go ahead and we can square this out. Quick way, square the first term here, so we're going to have x squared, multiply these two and double it, so we're going to have plus 2x change of x, and then we'll have plus change of x squared. We'll have minus x squared minus 7 all over change of x. All right. Well, we can simplify farther, I guess. X squared is cancel out. Other than that, it doesn't look like we can cancel anything else out. We have 2x change of x plus change of x squared minus 7 all over change of x. So that would be the answer for C. Okay, quick little discussion about domain and range. Domain is all the values, all the x values in the function. The range is all the y values in a function. We have an example here. Find the domain or range of the following function. In this example, it shows us the importance of the notation for f of x. Because if we were to graph what we're used to graphing, if we were to graph a square root graph, we'd say it's a sideways parabola because we were dealing with y equals plus or minus the square root of x, or square root of x. All right. Well, since it has a function notation, since it's saying it's a function, obviously this doesn't pass the vertical line test. So since it's saying a function, we're only dealing with the upper half of this graph because it's saying it's the positive square root of x minus 1. So we want to talk about the domain and the range for this function. Okay, so the domain is all the x values of the function. Well, what x values can we choose? Obviously, I didn't graph this one entirely correct. I didn't do my shift at all. It would be shifted one to the right since there's a minus sign here inside the square root. But what we know about square roots is we cannot have a negative in a square root, otherwise we get an imaginary number. So what we're saying is inside the square root would have to be greater than or equal to 0. So we would say that our domain would be x is greater than or equal to 1. So all the x values that are greater than or equal to 1 can be values we can choose for x. And then they want to know, so there's your domain. And then they want to know your range. If you look at your range, obviously we can't have any negative numbers for our y. We can't have 0, so our range is going to be our y is greater than or equal to 0. Okay. So that's the domain and range there. Just any values that work for x for the domain, any values that work for y for the range. Families of graph. Last year we talked about families of graph quite a bit. Hopefully you remember them. I gave you a website here on your notes that I'm going to show you right now that goes through all your families of graphs. That's just a line. Absolute value function is a v. X squared is a parabola. X cubed is a disco dancer. The square root is like we just talked about right there. Half of a sideways parabola because it's a function. 1 all over x graph. Remember all these from last year. So you have all this for your viewing, and even your sine and your cosine, and it gives us a step function as well. So that's all. On the internet for you on your notes, so you can watch. You can go review those, and I included all those right here, so we don't have to talk about that too much. The last thing we're going to talk about is transformations. We talked about. I hit on it a little bit earlier when I was talking about moving the f of x equals the square root of x minus 1, shifting it to the right because it was inside. All these rules right here are telling us the rules for shifting. All right, so this x minus c is saying we got to move it to the right. It's the opposite sign when it's inside of the parentheses. This is saying it's got to move it to the left, opposite sign. This right here, if it's outside, determines whether we move it up or down. In this case, it moves it down. In this case, it moves it up. When we have a negative out front, it actually flips it over the x-axis. Like if we had f of x equal the negative x squared, it would come down right here. All right. If it's inside, it's going to reflect it about the y-axis, so it'd turn on its side. And then if it's both a negative and the opposite of inside the parentheses, it's going to reflect about the origin. I also have another website to show you all that stuff right here. Just a simple function plotter. You'll see in the red is our original equation, or in the red right here is our original graph. In the green, I added 2 inside, so here is that graph to move it to the left. And the other one, in the blue here, I subtracted inside the parentheses, so I moved it to the right. In the orange, I have it the negative outside. And then in the purple here, I have plus 1 on the outside of the square, or outside of the parentheses, so it moved it up 1. All right. I don't think that's too tough. We hit on that quite a bit last year, so I'm not too worried about that. Here's your function for part 1 of the prep section, section 3.